Okay, so we're still dealing with going through the portfolio performance evaluation process. Now, we're still in the attribution section. Right now, we're going to talk about return attribution. And remember, we have to look at both return and risk. So risk is coming, but right now I want to focus on return attribution. So we've got arithmetic attribution and geometric attribution. So ultimately, again, what we're trying to do, like we seem to be doing a lot in finance, we are hunting for alpha. The holy grail of investing, if it even exists out there. That's what we're doing. We're hunting for alpha. So return attribution is going to let us determine which investment decisions taken by the portfolio manager were successful or unsuccessful in generating alpha. And remember, relative to a benchmark. And again, we're going to talk a lot about benchmarking. It has to be the appropriate benchmark. Okay, and as we get to the alternative investments, some of these are very, very difficult to benchmark. Okay, so let's move forward. So return attribution is basically just going to help us identify and quantify the performance of an actively managed fund versus its benchmark. You told me you can outperform the market. Prove it to me. Let's see it. Okay, so there's going to be two important equity return attribution methods that we're going to discuss today. The Brinson model and then factor-based attribution. Okay, now as we go through these slides today and we go through these topics, I want you to get into the habit when you see a data table, I'd like you to make a copy of that, print it out, or have your slide deck handy, because we're going to refer back to that data a lot, and I don't want you to get confused. There are a lot of moving pieces here, and again, I just want to make sure that it makes sense, and this is how I would approach it if I were a candidate. I can't remember a data table from 12 slides ago. Okay, so make sure you print out these, and I'll go through and tell you which ones I would print out and which ones we're going to take a deep dive in. Okay, so if we're going through this idea of arithmetic attribution and geometric attribution, what are we really getting at here? So all we're trying to do is to explain any excess return. So the portfolio earned this amount, R, and its appropriate benchmark return B. Okay, so that spread, that difference, that alpha, that excess return, I want to explain that. Okay, now geometric attribution improves on the arithmetic approach, and it's going to basically classify, now they're using geometric excess returns. Okay, so in this derivation that you see above, all we're saying is that the geometric excess return G is going to be equal to the ratio of the arithmetic excess return, this R minus B, over the wealth ratio of the portfolio's appropriate benchmark, or again, the 1 plus B. So, these things are nice to know, but I think it's more important to pull out what are we really getting at here. So what we're saying is arithmetic attribution is best suited for non-technical clients and marketing reports. Hey, most of us can add. That's not too bad. Geometric attribution is much more complicated. It can get a little bit more dicey. It's best suited for the industry professionals. That's basically, I just saved you 10 pages of reading from the source material. That's really the key point here. Okay, so let's get into some attribution analysis. And again, let's look at returns. So here's a total portfolio return attribution analysis. I think one of the biggest mistakes that candidates make when they're going through the exam, actually taking it and preparing for it, they kind of glance at the tables, but they don't stop for a second and really read them to see what they're saying. So I'm going to encourage you to not just glance at these tables that they give you, They're very important, and sometimes you can misread the table. It might actually say something different than you thought it did. So I want you to stop, take a little bit about that time that you have left over, because we're going to teach you a lot of time management skills. Not having enough time to analyze a table is not going to be a problem for you if you follow our methods. So our portfolio return was 8.05%. Our benchmark return was 5.05%. So that excess return is 3%. Now, okay, I know that it's 3%. I'm not a rocket scientist, but that sounds pretty good to me. But let's dig into it a little bit more. There are going to be some terms that we use today that, regardless of which model we're using, they're fairly consistent in their definitions. So I want you to be clear what these are saying. So what is an allocation effect? It basically is grading the portfolio manager on how good are they at sector weighting versus the benchmark. The benchmark has a 60% weighting, let's say, to finance. You have a 20% weighting to finance. You under basically weighted that sector. That's where it's going to show up in the allocation effect. Did you do a good job with that sector weighting as the portfolio manager? And that's going to be focused in the allocation effect. Then we have a selection effect. So what is a selection effect? It's just stock picking. You picked better stocks than that were in the benchmark, a better combination. Okay, so when we analyze this 300 basis points excess return, what do I see? Well, this portfolio manager is pretty good at allocating sectors and underweighting and overweighting them. In fact, that's 2% of the 3% excess return. And they're also pretty good at stock picking, which explain 1% of that 3% return. Okay, so that's how you're going to read this table. That's how I'd like you to read every table. I want you to go through, figure out what's going on, figure out the terms, or you're not going to have a chance of scoring well on the exam. Okay, so there's a 300 basis point excess return. And as I mentioned, the portfolio manager earned most of this excess return. In fact, 2% of the 3%, basically by these allocation effects or these sector weightings that they did. Now, in regard to stock picking, it was smaller effect, but it's still positive. So what insight can I glean from this? Well, it shows that the portfolio manager's ability to pick sectors was superior than their ability to pick stocks over the past 12 months. Okay, so if this professional is telling us that they're one of the best stock pickers, I don't think so. That's not what we see in this data. But if they tell us they use a combination, and that's exactly what happened here, and at least over this 12-month period, they did a better job at allocating sectors than they did stock picking, but stock picking was still positive. Okay, so now let's jump into the Brinson model. So the following equations are going to help you understand how to implement this model. Okay, so we have a portfolio return. It's just the weighted average of those individual securities returns. And we're going to compare that to the benchmark return, again, the weighted average of that benchmark. Okay, so we've defined that for you here. This is the slide. I want you to please print this out or have it handy when you're reviewing this lecture. We're going to be referencing back to this output a lot over the next period of time, and I need to make sure that you can understand what we're doing. Okay, so just like we did before, let's stop for a second and identify what we have. We've got sectors or industries. Here we've got finance and we've got tech. Okay, and then we have a total column on the bottom. Now this is the portfolio weight. This is the benchmark weight. Here we see the return from the portfolio, and here we see the return from the benchmark. Okay, so we know what we have going, and let's dig into it a little bit more. So we look at the finance sector. The weight in the portfolio is 0.20. The weight in the benchmark is 0.5. So this is underweight. The portfolio manager decided to underweight financials. Now the return from the portfolio was 6%. The return from the benchmark was 4%. Okay, now let's look at technology. Weight in the portfolio was 0.8. The weight in the benchmark was 0.5. The portfolio manager overweighted technology. Now let's look at the returns. Oh, not so good. The return from the portfolio was negative 12%. The return from the benchmark was 2%. Now let's look at the overall total. The return from the benchmark was 3%. The overall return from the portfolio was negative 8.4%. You know, not very good. So we got to figure out what happened here. Okay, so let's now start the analysis. And again, I'd like you to please print this page. I'm going to be referring back to this a lot over the next few slides. Okay, so return from the portfolio, you can see how we calculated it. It's just the weight that we had in the finance sector was 0.20. The return from the portfolio in the finance was 6%. We've got the weight in the technology was 0.8. And the return in the technology from our portfolio was 12%. The return from the portfolio was negative 8.4. We do the same thing with technology. We come up with 3%. So what was the excess return? So it's negative 8.4 minus 3. So unfortunately, the excess return here was a negative 11.4%. So quite frankly, terrible. Okay, so let's dive into this and let's use the Brinson model to help us get a better understanding of how this terrible return happened. Okay, so the Brinson model is going to quantify the portfolio returns into 3 attribution effects. There's going to be an allocation effect, a security selection effect, and then there's going to be an interaction effect. So let's go back to what we talked about before. What is an allocation effect? It just means how good is the portfolio manager at underweighting or overweighting sectors. You know, because we've talked about this before. The security selection effect, what is that? We're evaluating how well the portfolio manager did as a stock picker. Okay, and then the interaction effect. Anytime we have a model, there's going to be a plug to make sure the model adds up, to make sure this arithmetic return adds up to the returns that we see. So the interaction effect is a plug variable. A lot of these models that we go through are going to have plug models or plug variables. And we're hoping that this is going to be close to 0. If this plug is huge, then it means we don't have a very good model. Okay, so we're just doing the same thing we did before. The Brinson model's just diving in a little bit deeper. We're taking a look at how good was the portfolio manager at under and overweighting sectors, how good was the portfolio manager at stock picking, and then we have this interaction effect, which is the plug. Okay, so let's start with the allocation effect. The allocation effect, again, refers to the portfolio manager's decision to alter specific weightings versus, remember, the appropriate benchmark. So we want to know in this example, hey, the portfolio manager chose to underweight finance. Remember, finance in the portfolio was 0.20 versus the benchmark was 0.5 of the portfolio. Well, did it work out? Let's find out. So for a given sector, the contribution to allocation, let's dive into this a little bit more. So you have, and I kind of want to write some notes here that will help you with this. So when we're dealing with this contribution to allocation, or how well are we at picking sectors and overweighting, undering them, so basically this is going to be calculated as the difference between the portfolio and the benchmark weights. So we're looking weight of the portfolio minus weight of the benchmark, and then we're multiplying that by the sector return for that benchmark. So the benchmark, well, actually, let's do it this way. We'll say the sector return, we'll say benchmark return. Okay, so let me repeat that. This allocation effect is going to take the weight of the portfolio minus the weight of the benchmark times basically the return of the benchmark. Okay, so using the previous data, again, we have to refer back to that original slide. What do we see? Well, finance 0.20 was the weight of the portfolio. 0.50 was the weight of the benchmark, and then we multiply that by the return of the finance benchmark, and we come up with negative 1.2. We go through the exact same thing with technology. Now, what's the next step? Once we go through the individual sectors, then basically the total portfolio allocation effect, you're just simply going to add up each of these contributions to allocation. So what did we get? Negative 0.6%. So the portfolio manager decided to underweight the financial sector. Remember 0.2 versus 0.5? And the portfolio returned 6%. It actually exceeded the aggregate benchmark that we saw return, which was 3% in total. Okay, so this allocation effect was negative. Okay, so this decision to underweight financials, it lowered the overall excess return, and again, it resulted in a contribution to allocation of negative 1.2%. They did overweight tech compared to the benchmark, 0.8 versus 0.5, and the portfolio return drastically underperformed the aggregate portfolio of negative 12% to 3% for that aggregate benchmark. So overweighting tech increased the overall excess return, resulting in a contribution to allocation of 0.6, and the combined effect of underweighting finances and overweighting tech negatively contributed to the performance of the fund, and again, the combined allocation effect was negative 0.6%. Okay, I know this is a lot of work, and it just takes a little bit of practice and go through it. So again, make sure you print out that Brinson model example where we gave you with finance and tech. We're going to be using it a lot, again, to go through this full Brinson model so you have an example of how to do this. So again, is the CFA Institute likely to have you do all three attribution effects? Probably not, but they could certainly ask you for one of them. Or maybe they'll give you the data for one and then you need it for the other. Okay, so you're going to have to be prepared for it. Okay, so what is the second part? Okay, we just dealt with the sector attribution. Now we're going to take a look at the selection attribution. How well did this portfolio manager do picking out stocks? Okay, so the easiest way to think about this is I want to take some of this information and just kind of put it into better terminology. So how are we going to deal with the security selection effect? So we're going to take the weight of the benchmark this time, but now we're going to multiply it by the return of the portfolio minus the return of the benchmark. Okay, so again, these formulas aren't bad. You just have to keep practicing and to try to keep them straight. You know, Flashcards, note cards work great here. Okay, so again, for a given sector, the contribution to selection, so you're a good stock picker, is going to be calculated as the benchmark weight multiplied by the difference between the portfolio and the benchmark sector returns. We're going to find out, are you a good stock picker? You told us you were. Okay, so again, using the previous data, we have information on the Brinson model example on finance and tech. Okay, so now the weight in the benchmark was 0.5. 6% was the return from the portfolio, and the return from the benchmark in finance was 4%. Okay, you actually added 1% as a stock picker here. Now let's do the same thing for technology. The benchmark weight was 0.5%. The return of the portfolio in your technology portfolio was negative 12%. The benchmark actually earned 2% in technology. So unfortunately, you didn't do so well in technology. So just like we dealt with basically when we were dealing with sector effects, now we want to look at this selection effect, and we're going to sum these up. And so the total selection effect was negative 6%. So let's dig into and understand why. How did this happen? Why did this happen? So the portfolio's financial sector outperformed the benchmark sector by 2%. 2% times the benchmark weight of 0.5, that's a 1% contribution to selection. That's a big smiley face. I'm happy with that. Now let's look at the tech sector. Okay, not so good. So we earned negative 12%. The benchmark earned 2%. So we underperformed the tech sector's benchmark by 14%. Negative 14% times the 50% or 50% benchmark weight, we end up with a negative 7 contribution to selection from that tech sector. Okay, so overall, the combined effect was negative 6%. Okay, so now we need to dig into the third component, which is the interaction effect. I want you to think of this. This is the plug. This makes sure that the arithmetic return minus the benchmark is fully accounted for in the attribution analysis. And whenever you have a plug variable, I'm hoping this is very small. If it's not very small, we likely have a bad model, okay, or bad data. There's something going on. So now we're going to define the interaction effect. And again, is it likely that you're going to be tested on all three of these? No, not in one question, but you could get tested on all three of them over a combined number of questions. Okay, so for a given sector, the contribution to interaction is going to be calculated as the difference between the portfolio and the benchmark weights multiplied by the differences between the portfolio and the sector rates returns. Okay, so in English, let's make this clear. I like formulas. This is much easier for me to remember. I can't remember all of that stuff. So what is this? This is the weight of the portfolio minus the weight of the benchmark times the return of the portfolio minus the return of the benchmark. Okay, I think understanding these models, you know, if you're more of a visual person like I am, I'd rather just see the model. But we do have it written out as well. I don't care which method you use, just make sure that you understand it. You can bring it up on the exam and make sure that you can use this to help get points. So using the previous data for the financial sector, what do we have? Remember, we underweighted financials, 0.2 versus 0.5. We got 6. The benchmark was negative 4. So this added negative 0.6%. On technology, we overweighted 0.8 versus 0.5. Unfortunately, we earned negative 12%. The benchmark earned 2%. So this resulted in basically this interaction effect at negative 4.2, just like we've done on all three effects. We're going to sum them up to get the total interaction effect, and we come up with negative 4.8%. So again, as you prepare for this exam, you need to understand and take your time reading the chart, make sure the data table, you understand what's going on. Then I need you to make sure you've memorized these calculations, and just expect there's going to be some, maybe all of these on the exam, and just prepare for them. How do you prepare for them? You're going to continue to work problems and practice, practice, practice. Okay, so analyzing the results from that interaction effect, the financial sector, the portfolio weight was less than the benchmark weight, and there was a negative 0.6% contribution to interaction. And for the tech sector, the portfolio weight exceeded the benchmark weight, and there was a negative 4.2% contribution to interaction. So we've covered the Brinson model in pretty much detail. We've went through it, I think, about excruciatingly as I can. You got to work more of these problems. So let's jump into the factor-based return models. This is where it gets fun. I kind of like these. Okay, and we know these factor-based models. Fama French. The CFA Institute emphasizes the Carhart model, which I like a lot. So what does this do? This actually allows us to test the portfolio sensitivity to additional factors. Now, what does the Carhart model or any factor model do? So it's going to calculate, again, the excess return. We're still hunting for alpha. So we want to basically remove these factors that we know drive markets, and then whatever's left over, that's the alpha, okay? So basically the Carhart model consists of four components. We have a market index, we have a market cap, we have a book value to price, and we have a momentum. Now there are a lot of questions about what is the fifth factor. Stambaugh has a factor out there. Fama and French have now put out a 5-factor model as well, actually in 2015, and I'm actually working on a fifth factor myself. Hopefully to be published in the next year or so. Okay, so again, this Carhart model or any of the fundamental factor models, I want to basically calculate this excess return from known factors that influence the market so I can test this portfolio sensitivity. Okay, so this Carhart model, it removes the effects of known market factors, and I want to quantify this excess return from the portfolio management process. So what are we really saying? Did you get alpha? And when you look at this regression, where is alpha? It's right here. This is the alpha. This is basically the excess return when we remove the market index, we remove the market cap, we remove the value to growth, and we remove the momentum. Okay, so that extra is alpha. We've now got an output of a Carhart factor model. And remember, the Carhart factor is 4 factors. There's also a 3-factor model, Fama and French, and Fama and French in 2015 gave a 5-factor model. So we have 4 factors. So this is a slide that I would actually recommend that you print out and reference as we go through this. There's just a lot of things on here to understand, and it's easier to have it in your hand to see it. Okay, so the first thing I want to do, this output identifies the 4 factors. Okay, so we have a market index factor, we have our market cap factor, we have our value to growth factor, and then we have our momentum factor. The other thing I want to take a look at is I want to see the descriptions of the factor sensitivities between my portfolio and the benchmark. Okay, this is the difference right here. Okay, so when you look at my portfolio, what do we see? Well, the market index is 0.98. Small minus big is negative. so it's a large cap. We can look at high minus low as 0.30, so it's got a value tilt. And then momentum, winners minus losers, is fairly small at 0.09. Now let's compare that to the benchmark. Well, the market index is 1. That indicates a diversified index. Our market cap, again, is negative, so that indicates a large cap. And now we've got a 0 value tilt, and we have very small momentum. Okay, so those are things that I would want to pick up on. And then the other thing that I want to take a look at is I want to look at our contribution to active return, because you look at our active return, we earn 1.65%. Well, as you go through these 4 factors, which one of them had the most impact? Well, if we look at this value, we can see that's 1.29% of the 1.65% total active return. So that's a significant, the portfolio manager's decision to tilt towards value made a significant difference on this portfolio. Okay, so let's go in and analyze this a little bit more. So I mentioned at the benchmark, the sensitivity of the benchmark to basically the market index was actually 1, so it means it's a diversified index. Now, we also talked about with the benchmark that if we looked at that negative coefficient that we saw in market cap, that means it has a large cap focus tilt. Okay, and then looking at the benchmark, it had a 0 weighting in value to growth, and the momentum was very small sensitivity as well. So let's just summarize the benchmark, what we have. It's a large cap blend, there's no tilt toward growth or value, and it doesn't use momentum. Okay, so at least now we know what we're dealing with the benchmark. Now we have to take a look at the portfolio of the portfolio manager, and we want to compare that to the benchmark. And in column 3 of the sample Carhart factor model attribution sheet I had you to reference, that's going to show the difference between that portfolio and the benchmark. Okay, so what do we see? If we go back, and I'll write it for you. So the market index on our benchmark, on our portfolio, was 0.98. The market cap, which was small minus big, was -1. The value tilt was 0.30, and the momentum was 0.05. So when we analyze our portfolio, just understanding what we have, our portfolio is going to exhibit a value tilt. It's large cap as well, but it resembles the benchmark on the other factors. Okay, and you'll see that in the differences on column 3. Outside of the value tilt, our portfolio is pretty close to the benchmark. Okay, so now this is the most important thing. I want to figure out that value tilt that was taken by the portfolio manager. Did it add value to the portfolio? So this is where we look at the contribution to active return. And remember where I showed you when we were going through it, the value tilt was 1.29% of the total 1.65% absolute return. So that's over 78% of the realized active return came from that decision to tilt towards value. The other effects were very minor. And what we also see in the security selection, the portfolio manager's effectiveness at stock picking kind of slightly detracted from the portfolio by -0.10%. So again, the sample Carhart factor model attribution, it gives us a lot of information. And if this portfolio manager told me that he's a growth portfolio manager, I'd be like, well, that's interesting because your tilt to value is where you got most of your active returns. So again, you want to take this information and then compare it to what they're telling you. Did the portfolio manager do what they said they were? You told me you were a good value manager. You're right, you are, and I can demonstrate that. Okay, so now we're going to get into fixed income attribution, and I want to warn you on this section, this can get pretty dicey, and I just want you to understand for the exam, you are not responsible for any fixed income attribution calculations, but you are responsible for interpreting the output. Okay, so what I'm going to do is give you a 30,000 foot level overview of fixed income return attribution. I need you to do the next step. You're going to have to work some problems. I would reference our Kaplan material, our Schwesser notes are fantastic. And I would also go to the CFA source material here. There is a lot going on. And again, there's no calculations that you're responsible for, but you're going to be held responsible for understanding the output. Okay, so you're going to have to spend some extra time here. More time than I can cover. You're going to have to really put some work here. Okay, so there's 3 methods to fixed income attribution. So we have exposure decomposition, which is going to be based on duration. We also have a yield curve decomposition. Again, that's duration based. And then we're going to have a yield curve decomposition, but now we're going to use full repricing based. So we've got some different methods. We've got basically some different ways to do these as well. Okay, so for the exposure decompensation using duration, it is a top-down method. It utilizes duration to quantify any decisions that the portfolio manager made regarding interest rates relative to the benchmark, and it's going to segment risk by some specific characteristics. That's why it's an exposure decomposition. So in this example, it's basically impacting, it's looking at portfolio results from interest rate risk, and it's going to use duration segmented portfolios, and it's going to assign these securities into duration buckets. And it's going to be based on the security's maturity. Now, as we go into yield curve decomposition, again, still duration based. Now this time it's not just top down, it could be top down or bottom up, and it's going to utilize duration and yield to maturity in computing price return. Okay, so we've got the percent total return. It's going to equal the percent income return plus the percent price return. And remember, on that price return, it's approximately equal to negative duration minus the change in yield to maturity. So just a little helpful formula there that might come in handy. Now, this yield curve decomposition, it's going to be based on what duration looks like and what factors drive these returns when the yield to maturity changes. So when used on both the portfolio and the benchmark, we can make a comparison of these return drivers, and we can determine the impact of active management. So just like we did in the other models, we're just trying to figure out, did the actions taken by the portfolio manager add value to the portfolio, or did they not? This is just one of the many methods in fixed income that we can do to do this. Now, compared to the exposure decomposition, this unfortunately is more complex and it requires more data. So again, we're limited to which models that we select, just depending on what data we have available. Okay, and then we have the full repricing method, which is the third measure of yield curve decomposition. So we can actually reprice these securities using spot rates or zero coupon curves. We call this the full repricing method, and it is the most accurate. So this is important. It is the most accurate measure of price changes in the securities. Now, here's a weakness of this. It's frequently more difficult, and it's generally much more expensive to use. So again, every one of these, there are pluses and minuses. I need you to understand both the strengths and weaknesses. No model is perfect. And I cannot stress this enough. See the Schweitzer notes and the CFA Institute source material for fixed income exposure decompensation analysis examples. And again, don't worry about the calculations. I want you to focus on interpreting the results. Okay, so now we've talked about return attribution. Well, let's talk a little bit about risk attribution, because remember, risk and return are two sides of the coin. So choosing the appropriate risk metric attribution analysis, it's going to require an in-depth understanding of the process by the portfolio managers. So you're going to have to identify, is it top down or bottom up, and what is the appropriate benchmark. Okay, and again, if you just look at returns, it is insufficient to evaluate the process. Risk taken by the portfolio manager to earn those returns, it needs to be analyzed. Okay, and this risk attribution is going to identify the sources of risk taken by the portfolio manager that resulted in that fund's returns. So just like we did with return analysis and attribution, I want to isolate decisions that the portfolio manager did that impacted the portfolio's risk, now that we're looking at risk attribution. Okay, so risk attribution, again, this is an important chart. I would absolutely take some time to review this. I think it's very helpful, but it gives you an investment process. So notice we have a top down, we have a bottom up, and we have a factor base. Okay, so we've got three processes here to define. Now, what if we want to figure out which type of attribution we're going to use? Well, we can use relative or we can use absolute. So for instance, in bottom up, we're going to use the security's marginal contribution to tracking risk, also called tracking error. For top down, we're going to attribute that tracking error to relative allocation and selection. And then in factor base, we're going to take that factor's marginal contribution or contribution to tracking error, and then we're going to focus on active specific risk. Now, in the absolute side, we can see in a factor base and the top down, we're going to look at the factor's marginal contribution to total risk, and we can also drill deeper into specific risk. So I like this table. It's just a nice handy cheat sheet. So again, we've kind of discussed these terms on the slide. One area that I want you to think about, when you get into absolute attribution analysis, a common risk measurement is going to be standard deviation. So remember, when we're dealing with alternative investments, this assumes a normal distribution. Is standard deviation an appropriate method for you to use to try to summarize what's going on with your fund? Okay, so risk attribution, we can use a bottom-up approach. So as the table indicated, each security is going to have a marginal contribution to tracking risk, and then we're going to multiply that by its active weight to determine the contribution to this tracking risk. And using a top-down approach, this is going to be more of a macro approach, and we're going to attribute active return to allocation. And what are we trying to do here? We're basically going to attribute tracking error to both allocation and selection. So again, it's sort of the same processes over and over and over. We're just having some slight tweaks. Okay, so return attribution. If we're looking at macro, remember, this is at the fund sponsors level. Okay, so the fund sponsors first going to determine the strategic asset allocation. Now, assuming the fund sponsor hires external portfolio managers to execute these tactical asset allocation changes, macro attribution is going to allow us to figure out, was this a good move? Should you have overweighted that sector or underweighted that sector? So suppose for the purposes of equity allocation of a balanced fund, the fund sponsor hires 2 external portfolio managers, one to manage growth and the other to manage value. Okay, so we have a nice return attribution analysis output display for you. So again, this is another slide that I would recommend that you print out, that you have available. But anytime you see a slide, I want you to take a couple minutes. I really want to take a couple minutes, but a little bit of time, and I want you to review it. So again, what are we focused on here? Growth portfolio managers and value portfolio managers. So what do we have? We have the fund weight, we have the fund return, we have the benchmark weight and the benchmark return. So let's take a quick look into this. The growth portfolio manager, he decided to weight 22% of the fund into growth. Now the benchmark weight was 25%, so they underrepresented growth in the portfolio. Now when we look at the return, the fund earned 0.82%, the benchmark earned negative 1.08%. Now we look at value, fund weight was 0.78. The benchmark weight was 0.75, so they actually overweighted value and they underweighted growth. Now when we look at the returns, the fund earned 0.99% versus the benchmark of 0.32%. And whenever you see a return attribution, I want you to get in the habit of looking at the overall benchmark return. That can be very helpful. Okay, so now we have to go back and dig through the allocation and the selection and interaction effects. Okay, allocation, what does that mean again? Did they do a good job underweighting or overweighting sectors? So the decisions to overweight or underweight growth, did it make sense? So let's take a look. Remember in growth, they underweighted it. So basically the fund weight was 0.22, the benchmark weight was 0.25. Now the benchmark return was negative 1.8. Now the overall total return for the for the benchmark was actually negative 0.03, resulting in 0.03%. So the growth stocks underweight by the fund sponsor by 3%. It underperformed the fund's total aggregate benchmark by 1.05%. Okay, so then we can take a look at the selection and the interaction effects. So we take a look at the 0.25, which is the benchmark weight. We take a look at the 0.82%, which is the growth fund returns. Then we're going to subtract that from the benchmark growth return of negative 1.08, and then we're going to add to that our interaction, which is the 0.22, because remember we underweighted the underweighted the growth to the benchmark of 0.25, and then basically we take the fund return for growth, which was 0.82%. We're going to subtract the actual growth benchmark return, and we come up with 0.42%. So the growth portfolio manager outperformed the growth benchmark substantially by 1.9%. So the fund sponsor's manager selection decision increased portfolio return in this example. Okay, so this is how it can be so helpful to, you see the returns, but until we can attribute who did what and did they make a good decision, then we actually have something very valuable. Okay, so we can also take similar analysis for the hiring decision now of a value portfolio manager. Okay, so again, we're still looking at return attribution. We are still at the sponsor level. Okay, so we have a growth portfolio manager and we have a value portfolio manager. So what I want to look at, what do we have? Selection and interaction. So stock picking and the plug. And then we have the allocation, so sector weighting. Okay, so what do we see in this growth portfolio manager? Well, selection and interaction was about 0.42%. Sector allocation was 0.03% for 0.45%. When we look at the value portfolio manager, again, the stock picking was about 0.52%. Not very well in sector, very small, 0.01%, for a total of 0.53%. And overall total, we ended up at 0.98%. Okay, so again, calculations for the small cap value equities portfolio manager, going back to the original table, the return attribution, go back to your small cap value equities, and you can basically go through the allocation effect and the selection interaction effect. So the allocation effect, in the small cap, the fund weight, the weight of the fund was 0.20. Okay, the 0.25 was the benchmark weight. Then we're going to multiply that by the benchmark return. And then we're going to subtract the total overall benchmark return of 0.03, and we come up with allocation effect of negative 0.08%. Okay, so now we have to do the selection and interaction effect. So first thing we're going to do, the benchmark weight for small cap value equities was 0.25. Then we're going to take the fund return, which was 2.39%. We're going to subtract the benchmark return, which was 1.52%. And then we're going to take care of the interaction effect. So again, 0.2 versus the benchmark of 0.25. We underweighted small cap value equities in our overall portfolio. We have the fund return of 2.39%. We're going to subtract the benchmark return, and we get overall 0.17%. So again, I know it's a lot of work, and it's unlikely you're going to have to do all of these for the exam question, but they may ask you for the allocation effect, or they may ask you for the selection interaction effect, or maybe you will have to do all three. It doesn't matter because you're going to be prepared. Okay, and then we can actually go into micro attribution. So now we're at the PM level instead of at the sponsor level. So let's take a look at what we have. Again, we've got return attributions, we've got growth portfolio managers, value portfolio managers, we've got fund weights, we've got the selection interaction, we've also got the total, which again is 0.98%. Okay, so as we review this, what did we see? So overall, the good security selection in all three investments added 1.05% to the portfolio. The allocation decisions unfortunately reduced the overall return by 0.07, and we saw marginally positive allocation effect in small cap growth that was offset by two marginally negative allocation effects in small cap value and then actually in large cap value. So again, I know it's a mouthful. I know this is a lot of work in this section, but attribution is heavily tested on the exam. You need to feel comfortable with this material. The only way you're going to get comfortable with this material is you're going to have to practice. You're going to have to work a lot of practice problems and get in the habit of trying to see the big picture here. So we have a selection and interaction effect. We have an allocation effect. Do you remember what they are? Do you remember how to use them? Because that's what you're likely to be tested on. So again, keep working. I know you can do this, and try to look at this as a 30,000 foot level before you go running off in the weeds somewhere. You can do this. I did it, so can you.